Hello guys, good day. Welcome to our summer coaching series, and this is for basic 9, those students that in the next term they are going to be in basic 9, and this is factorization. We're going to be looking at topic factorization. Don't forget, we'll be looking at so many topics. I think this should be our third or fourth lesson. We've looked at whole numbers. There is a whole number. We look at number basis. The last topic was number base. So today we're going to be looking at factorization. And what we learn today is expand, how to expand, and how to find the HCF of expression, algebraic expression. Now, an algebraic expression with two terms is known as a binomial expression. Binomial expression. Binomial expression. Binomial expression. An algebraic expression with two terms. Look at this. This is a binomial expression. It's an algebraic expression that has two terms. This is the first term and this is the second word term. So this is a binomial expression. So we are going to be looking at removal of brackets. How do you remove brackets? What does it mean to remove brackets? Take this example. You have 2 into bracket 2x plus y. How do you simplify this? How do you solve this? Or how do you remove bracket? It's very simple. To simplify this, please pay attention. To simplify this, you have to remove bracket. How do you remove bracket? What is outside will multiply what's in the bracket. Now there are two terms in the bracket, so this 2 we have to multiply both terms here. 2 will first multiply x, then 2 will multiply what? Y. So 2 will multiply this 2x and 2 will multiply what? Y. Did I call it x earlier? So it's 2x because 2 and x they are espoused. So 2 will multiply 2x and 2 will multiply what? Y. 2 times 2x is what? 4x. 2 times y is what? This plus 2 what? Y. Take note that this 4x here is also positive. The reason as long as there's no negative here, a number is what? Positive. Whether the positive is written or not. So expanding this will have what? This. So let's take another example here. Let's take another example. Okay, what if we have this? What if we ask to expand this? 8p plus 3b bracket, open bracket, close bracket, 5a. Now take a look at this one. 5x, let me use x. Take a look at this one too. Now this is not different from this. It's just that here we have this term after the bracket. Bracket in mathematics means what? Multiplication. Take note of that. When you have bracket in mathematics, it means that you should multiply. So what do? We have to multiply words outside the bracket by words in the bracket. So it means that 5x rather will multiply 8p, and 5x will also multiply what? 3b. That's what it means. So 8p times 5x, 8 times 5 is what? 40. P times x is what? Px. 3 times 5 is what? 15. B times x is what? B what? X. And both positive. This is positive and this is positive. So you have 40px plus 15b what? X. So it means that our answer is what? 40px plus 15b what? X. 40px plus 15b. Now, okay, let me take it. 5x times 8p. 5x times 8p. First multiply the numbers. 8 times 5, 40. B times x. P times x, px. 3 times 5, 15. B times x, bx. Both are positive, so you have positive. That's how you get your answer. That's how you get your word answer. So let's take further examples. Let's take further examples. What if you have this? You can have this 5 into bracket minus x minus 3y. What if you have this? 5 we have to multiply minus x and 5 we have to multiply minus 3y. It's not difficult. This 5 is positive. Positive times negative is what? Negative. Positive times negative will give you what? Negative. A positive number or a positive terms multiplied by a negative number or term will give you what? Negative. Negative times positive will give you what? Negative. Positive times positive give you what? Positive. Negative times negative give you what? Positive. When you have different signs, you get a negative. Different sign, you get a negative. The same sign, you get a positive. The same sign, you get a what? Positive. So negative times positive give you what? Negative. 5 times x will give you what? 5x. Positive and negative give you what? Negative. 5 times 3y will give you what? 15 what? Y. Now 5 does not have a 5 is not an algebraic expression here in the sense that it is just a whole number. It does not have a letter. So 5 will now multiply this 3 to get what? 15. Then this y, they will both share this what? Y. So this is our answer. These are what? Answer. These are what? Answer. Very, very, very simple. These are what? Answer. These are what? Answer. Now let me give you a final example for the road before I go to HCF. 2t into bracket 5t minus 7h. So how do you multiply this? Very, very simple. 2t will multiply 5t. 2t will multiply minus 7h. 2t times 5t. 2 times 5 is what? 10. T times t is what? T square. A letter multiplied by a letter will give you that letter what? Square. Just like 2 times 2 is same thing as 2 square. Which is what? 2 square is what? 4. So if you have x times x, will give you what? X square rather. If you have h times h, will give you h raised to power what? 2. This power here is talking about the normal occurrence of this h. Now let's take it higher. H times h times h will give you h to the power of, how many times is h occurring? 3. So are you with me? Are you with me? Now let's go ahead. Let's go ahead. Now plus times, we want to multiply 2h by 7, 2t rather by 7h. Plus times minus, minus 2 times 7, 14. T times h is what? ht. H what? T. We tend to write the numbers in alphabetical order. G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U. So h comes before t, we write ht. We write the number in alphabetical order. If you have 2 or more letters, did I just say numbers, please? Sorry. If you have 2 or more letters and you want to write them together, you write them alphabetically. T comes before H, or H comes before T. Which one? H, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. So H T instead of T H. Although it's still the same, but we follow alphabetical order when we're writing 2 letters in mathematics, in algebra particularly. So that's it. Now today we go to highest common factor. Highest common what? Factor. Highest common what? Factor. Remember how to find the HCF of numbers. You remember how to find the HCF of numbers? Yes. HCF of numbers, I must have done in JS1. But when we come to algebraic terms, how do you find the highest common factor of 2 algebraic terms? I will have to erase this. I hope you've written it. Highest common factor of 2 algebraic terms. Highest common factor of algebraic terms. Highest common factor, HCF. Find the HCF of this. If you have to find the HCF of CXY and 18x squared, there are 2 ways of doing this. There are 2 ways of finding the HCF of this. There are 2 ways of doing it. There are 2 ways of doing this, of finding the HCF of this. Let me show you this way. Sorry for that. Let me show you this way. Find the HCF. 6xy, 18x squared. To find the HCF, first you do it, you divide by, let's deal with the numbers first. Let's divide by 2. 6 divided by 2 is 3. 3xy, write the xy. 18 divided by 2 is 9, 9x squared. What else can divide this? 3 can divide this. 3xy divided by 3 is xy. You have 3x what squared. Is there any other number that can divide it? No. Why? There's no number that can divide both of them. No number that can divide both of them. the numbers must, just like you are looking for the HCF of number, or should I use a number? I can never use number as example. Okay, remember, I'm coming please. Let's say you want to find the HCF of 10 and 20. Remember this method, 10 and 20. You divide by what can divide both of them. 2 can divide both of them. You have 5 and 10. What can divide both of them? 5. 1 and 2. Now, 1 divided by 2 give you a fraction. 2 can be divided by 2, but 1 divided by 2 give you a fraction. So it means that the HCF is what? 10. 2 times 5, which is what? 10. You stop here. 2 times 5, 10. Remember that. So we'll do the same thing here. We'll apply the same thing here. Look at what we'll do. We say 6xy, 18x what square. You begin to divide. 2 can divide both of them. You have 3xy. See, 18x squared divided by 2, you have what? 9x squared. 3 can divide both of them. 3xy divided by 3 we divide 3, you have what? Xy. 9x squared we divide 3, you have what? 3x squared. Having done that, you have, this is 1xy, same thing as 1xy. You have 3x squared. Nothing, no number can divide it again. So we now move to letter. Which letter can be divided? Okay, which letter can divide both of them rather? You see that there's x and there's x. It means that this can be divided by x. Let's divide by x. Xy divided by x. X will cancel x. You are left with what? Y. Now x squared divided by x. Don't forget that x squared is x times x. X squared is x times x. Now let's divide by x. X will cancel x. You are left with what? X. So you can see that 3x squared divided by x. Don't forget the 3. 3 is here. You have 3 what? X. So is there anything that can divide this? This y and this x. This is 1y and 3x. There's nothing that can divide this. So it means that your HCF will be the multiplication of what you have here. 2 times 3 times x, which is what? 6 what? X. That's your HCF. That's your HCF of these two. Very, very simple. Very, very what? Simple. Very, very, very simple. Now let's take the second one. 3x and 15y. Let's find the HCF. Want to find the HCF? The same thing we do. You have 3x here. You have 15 what? Y. Now what can divide 3? Take the numbers first. What can divide 3 that can divide 15? Yes, 3 can divide both of them. So we have 3. 3x divided by 3 is what? 1x, which is x. 15y divided by 3. 15 divided by 3 is what? 5 what? Y. So is there anything that can divide x that can divide 5y? This is 1 and 5. Nothing can divide 1 and 5. This is x and y. Nothing can divide. So it means that our HCF is just 3 here. HCF is what? 3. 3 is the biggest term that can divide both 3x and 15y. There's no algebraic term apart from 3, or there's no number apart from 3 that can divide 3x and 15y. So that's the HCF. Now let's take it higher. Let's look for an higher example. I'm sure you've written this. Let's take it higher. So let's take it higher. Let's take it higher. Let me look for something else. Let me take it higher. Let me not use what as x. 10ax squared. Okay, still as x, but I think this example is sufficient. 14a squared x squared. So let's find the HCF of this. So you have 10ax squared, 14a squared x squared. So the first, let's deal with the numbers first. 2 can divide. 10 divided by 2 is 5ax squared. 14 divided by 2 is 7. Then you leave down your a squared x squared. So there's nothing else that can divide 5 that can divide 7. No, there's nothing that can divide 5 that can divide what? 7. Nothing can divide 5 that can divide what? 7, right? So we'll go to the numbers, the letters rather now. A squared and a. A can divide a squared and a can divide a too. So let's use a. 5ax squared divided by a. A will cancel a. You're left with what? 5x squared. 7a squared x squared divided by a. Now this a squared is a times a, right? So a will cancel one of the a, so we're left with the other a. So you have 7ax what squared. Now look at it. What can divide both? No a here, there's a here, so we cannot divide by a. 5 and 7, nothing can divide both of them. But look at x squared. X squared is here and x squared is here. It means that we can cancel out x squared by dividing by x squared. So let's divide by x squared. X squared will cancel, so we have 5 here. 7 8 x squared. X squared will cancel, so we have what? 7 what? A. So it therefore means that the HCF is 2 times A times x squared, which is 2ax what squared. 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 Do you need any more example? You need any more example? I don't think you need any more example. I don't think you need any more example. Let me try to see if I can break this here. Okay, I don't think you need any more example. Now, there's a reason why we've learned HCF. There's a reason why we've learned what? HCF. Okay, let me give you one example and let me give you something to do. I will break this class into two. I'll break this class into two. I think I can do that. I can break it into two. I think I can break it into two. I can break it into two. Yes, I'll break it into two. So let me give you one more example. Then I give you something to do. Okay, let's take this. A B square and A squared B. Remember I told you that you should be cautious when solving mathematics. Now A B square and A squared B. Let's find the HCF. A B square A squared B. Now A and A squared, A can divide both of them. There are no numbers here, so you move straight to the letters. A B squared divided by A, you have what? B squared. A squared be divided by A squared divided by A. A squared is same thing as A times A, remember. So A will cancel one here, left with what? A, B. So this is B squared, right? B can divide B squared. So let's use B. B squared divided by B is what? B. AB divided by B is what? A. So our HCF is what? A times what? B. Which is what? AB. Sorry, I have to write it as AB. AB. So quickly do this, and I would like to see it when we have our one-on-one session. Quickly do it. So you have written this. Do this. So quickly, first, remove brackets, classwork, your assessment, remove bracket from the following. Number one, minus 7s plus t 6 y into bracket y minus 1 and the bracket 3n minus 2y. Then the last but not the least, minus 9 into bracket minus 2 minus 3 q. This is q. So then find the HCF of the following. Find the HCF. Number one, 13AB and 39B. This 39B, please. Let me repeat it because my head looks might be 13AB and 39B, please. Second one, 7MNP and MP and MP. The third, 8PQ and 24P square. So find the ACF of the 3 and remove bracket from this 4. So thank you for this. Thank you for joining with me here. I see you in the next lesson. Bye. Sorry, so let me adjust the camera so you can see.